Hey everybody, in this video we're going to go through lesson 0.06, solve complex linear equations. So hopefully you've gone through the previous lesson where you were solving linear equations. Now we're going to kind of step up a little bit. So let's first talk about some general solving tips. Your goal is always to isolate the variable. We have to remember that property of equality. When we're isolating this variable, we're going to use those opposite operations, and you need to do each operation on both sides of the equal sign. If you can hear my cat, I apologize. I always say he has to make it in before I close the door, and he didn't do that this time. So now he's out there just wailing. All right, do each operation on both sides of the equal sign. If you're not sure what operation you should be doing first, use opposite order of operations. So parentheses, exponents, multiplication, division, and then addition, subtraction. And I don't know why I wrote it with the slashes in there. But you do opposite PEMDAS. So start with addition, subtraction, and work your way up. Always, always, always check your answer. Plug it back in and see if it works. All right, let's look at some examples. Number one, we are going to solve for b. And we have 4b minus 2 equals 20. And the fun part about this problem, looking at the left-hand side of my equals sign, I notice that I have 4 times b minus 2. So I actually have choices here. I could divide by 4. Since this is 4 times b minus 2, I also could distribute the 4. Both will work. However, I'm going to tell y'all, if you can divide, that is quicker. It is a step shorter. So looking, if I were to divide both sides by 4, I would want this right-hand side to be divisible by 4, and 20 is divisible by 4. So let's start by dividing. So I'm going to divide both sides of my equation by 4 to get rid of the 4 that's being multiplied to b minus 2. And looking on the left-hand side, the 4 in the numerator and denominator cancels, leaving us with just the b minus 2. And it doesn't really need parentheses anymore. And that is equal to 20 divided by 4, which is 5. And now, to get b all by itself, I need to get rid of this minus 2, so I'm going to add 2 to both sides. Negative 2 and positive 2 will cancel each other out to 0, so we'll be left with just b is equal to 5 plus 2 is 7. And then I really always will check our work because it doesn't take but a second. So checking our work, we have our original equation was 4 times b we found to be 7 minus 2 is equal to 20. So using our order of operations now, 7 minus 2 on the inside gives us 5. So I have 4 times 5, which sure is 20. All right. Number 2. Let's solve for j. We have 10j minus 1 is equal to 7j plus 26. Looking at this equation, I see variables on both sides of my equal sign. And if our goal is to isolate the variable, it has to be on one side. So goal is to isolate variable on one side. Our variable is j. So to do that, I'm going to need to move one of these j terms over to the other side. And we can do that using our opposite operations. I could either move this positive 10j, or I could move this positive 7j. And if I were to move either of these, I'd have to subtract since they're positive. I think I'd rather subtract 7j. So I'm going to subtract 7j from the right side and from the left. Now, if I subtract it from the left-hand side, I'm going to subtract it with the like term 10j. 10j minus 7j. I can't subtract 7j from 1. So 10j minus 7j, 10 minus 7 gives us 3j minus 1. Just bringing this minus 1 down. And that is equal to the 7j minus 7j will cancel, leaving us with just 26. Now, continuing to try to get j all by itself, I am going to use those opposite order of operations and addition subtractions at the end normally of order of operations. So I'm going to begin with that now when I'm solving. I'm going to try to get j by itself. I need this minus 1 to go away. I'm going to add 1 to both sides then. Undo that subtraction. Negative 1 plus 1 cancels out, which is great. And we are left with just 3j. So we have 3j is equal to 26 plus 1 is 27. Now our last step to get j all by itself is to undo the multiplication that's happening here. So I'm going to divide both sides by 3. The 3 over 3 will cancel, leaving us with just j is equal to 27 divided by 3, or 9. Now, you know me, I'm going to check my work. So our original equation was 10, and then we found j to be 9. So 10 times 9 minus 1 should be equal to 7 times 9 plus 26. So let's do some quick calculations. 10 times 9 is 90. So we have 90 minus 1 is equal to 7 times 9 is 63 plus 26. And then we can just add. 90 minus 1 is 89. And 63 plus 26 is also 89. So that is true. Love it. All right, we're going to do 2 more. Please, if you need to pause it, come back in a minute or so, please do so. Number 3, we're going to solve for g. And this is negative g is equal to negative 2 times 3g minus 5 minus 10. Looking at this equation, I notice g is on both sides of the equal sign. That's a problem. But I do like, right off the bat, that this g is kind of all by itself over here. That's a good start. But looking at the right-hand side of this equation, I notice I have this negative 2 times 3g minus 5 minus 10. I can't just divide by negative 2. If I were to do that, I'd have to divide everything by negative 2, which we could do, but it gets a little bit messy. So I am going to instead distribute this negative 2 to the 3g and to the negative 5. So when we do that, negative 2 times 3g gives us negative 6g. So I have negative 6g, and then negative 2 times negative 5 gives us positive 10. So I have negative 6g plus 10. And then outside of that, we have the minus 10. And that's all equal to negative g. Now, I really hope y'all notice this plus 10 and this minus 10. Oops, I didn't mean to do that. These are just going to cancel each other out to 0. So I have negative g is equal to negative 6g. And I really just need to get g all by itself. So I'm going to move one of these over. It does not matter which one. I'm going to go ahead and move over the negative 6g. It's negative, so to move it, I will add 6g to both sides. on the left-hand side, this is like a negative 1g. So negative 1g plus 6g is 5g, which is equal to the negative 6g plus 6g canceled out. So that's just equal to 0. And lastly, to get g all by itself, I would just divide both sides by this 5, which doesn't really do much because 0 divided by 5 is just 0. So g is equal to 0. Now I'm going to check my work. Our original equation is negative, and then 0 is equal to negative 2 times 3 times 0 minus 5, and then outside of that, minus 10. I hope we all know negative 0 is not a thing. 0 is neither positive nor negative. So that's just 0, which is equal to negative 2 times 3 times 0 is 0. So we have 0 minus 5 minus 10. 0 minus 5 is negative 5. So we have negative 2 times negative 5 minus 10. And negative 2 times negative 5 is positive 10. So we have positive 10 minus 10, which sure is equal to 0. So that does work. Last one. This last one is one of my favorite types of problems. So this problem we will solve for x. Our equation is 11 plus 2/9 x, which is equal to 23. I like to call these equations freaky fraction equations. Fractions are representing division in some way. If it has a numerator other than 1, then it has some sort of multiplication in there too. But don't let this scare you. We can apply a little bit about what we know about fractions to make this easier. So one thing I want you to note, this 2/9 x is really 2/9 times x. So we have 2/9 times x, which is really the same thing as 2/9 times x over 1, because I can always take any number and divide it by 1. And then if I just multiply these two fractions, that's 2x over 9 times 1 is 9. So this piece right here, I'm going to replace with 2x over 9, and that's going to be helpful, and you'll see why in just a second. So our whole equation that we're going to solve is 11 plus 2x over 9 is equal to 23. Now, I am going to split this down the middle to help myself. Using our opposite order of operations, I need to get rid of this 11 first, and this is a positive 11, so I'm going to subtract 11 from both sides. The positive and negative 11s will go away, so we'll just be left with the 2x over 9, which is equal to 23 minus 11, or 12. Now, we're going to keep using our order of operations. Remember, this is division here, so we really have 2x divided by 9. I can get rid of that division. So I am going to get rid of the dividing by 9 by multiplying both sides of this equation by 9. That's going to undo the division. So the 9s will cancel. We'll be left with just 2x is equal to 12 times 9, which is 108. And then our last step is going to be to simply get rid of this 2, which is being multiplied to x. So I'm going to divide both sides of the equation now by 2. And we get that x is equal to 108 divided by 2, or 54. And we can also check our work. So, looking at the wrong one. Our original equation was 11 plus 2/9 times x, which we said was 54. And that should be equal to 23. So looking at the left-hand side here, 2/9 times 54, that's really 54 over 1. So we have 2 times 54 over 9 times 1, or 9. And we just did we just divided a number by 2 and got 54. So hopefully it feels familiar that 54 times 2 is the original number we had, 108. So I have 11 plus 108 divided by 9 should be equal to 23. And 108 divided by 9, I know that sounds really scary, but that is just 12. So 11 plus 12 does equal 23, and that equation is true. You may stop watching the video now if you would like, or I'm also going to show you an alternative way to do this last problem. And this is actually how Delta Math would tell you to do this problem, but I do it a little bit differently. So here is our original equation, and I'm going to do it a different way. So 11 plus 2/9 x is equal to 23. So I am just going to treat this like an equation, with this 2/9 being a coefficient. So 11 is positive. I'm going to subtract it from both sides. So I'll subtract 11 from both sides. The 11s will cancel, and we'll be left with just 2/9 x is equal to 12. Now this 2/9, this is just a number that's being multiplied to x. So I can divide by that number. So I'm going to divide both sides of this equation by 2/9. So I need to divide 12 by 2/9. And I hope at least this rings a small bell, but anytime you are dividing by a fraction, really that's the same thing as multiplying by the reciprocal. So this is the same thing as 12 times the reciprocal here, which means we're just going to flip the numerator and the denominator. So 12 times 9/2. And 12 times 9/2 is 108/2, which is 54. So that's an alternative way of doing this problem. It's just a little bit different thinking of this 2/9 as a number that you could divide by, but it is just a number that is being multiplied to x. So we could divide by that number. It just gets a little bit hairy for a second, but then it turns out okay. Please let me know what questions you have, and I look forward to seeing y'all in class.